Hello viewers on YouTube. In this video tutorial, we are going to consider linear acceleration. Now some of you might be wondering, what exactly is linear acceleration? From the word linear, it's simply the acceleration of an object that is moving on a straight line. Now when it comes to problems involving linear acceleration, 4 formulas are expected to help us to succeed in solving those problems. And the formulas are what we'll be considering putting into account and how to make use of them effectively, and most especially how to know which to use and when to use. So let's begin with the formula for acceleration or for linear acceleration. Now we know that the acceleration of an object A is given as the change in velocity v minus u divided by the time taken for the changeover, where v is the final velocity and u is the initial velocity. Now upon cross multiplication, or in other words, if we multiply both sides of this equation by the time, notice that we now have a t to be equals to v minus u. Now what we'd like to do at this point is to solve for v, and to do that we can add u to both sides, or better still, this can come to the side. So therefore we have at plus u to be equals to v, and this equation is the first equation you have to be familiar with while dealing with problems involving linear acceleration. That is, you can always find the final velocity of an object as long as the acceleration or deceleration is given, the time taken, likewise the initial velocity. Or whatever, if they're starting at rest, then it means u will be 0. Please keep that in mind. An object that is starting at rest, the initial velocity will be 0. But when a brake is applied to an object, the final velocity will be tending to 0. Now, when an object is moving on a straight line, s, or a distance or displacement, because distance can be the same thing as displacement this time around. Distance is a space or gap between 2 points, but displacement is that distance on a specific direction. Now, when an object is moving on a straight line, it's overcoming a space or gap. But since the straight line has been attached, it's a displacement as well. So distance or displacement, when distance is equal to displacement, then average speed will be equal to average velocity. So to find distance or displacement, we need to find the average speed. Since we said that speed or velocity is equal to distance over time, the distance will be the product. So taking the average, we have u plus v, the initial velocity plus the final velocity divided by 2. We are taking the average, this is the first one, this is the second one. So we are dividing by 2. Okay, then entirely multiply by 2. So this is the second formula. Alright, the second formula. For an object that's moving on a straight line, to find the distance, you need the average speed. So multiply by the time. Okay, don't just use speed like that. How to get out? Because this distance is equal to displacement. Perfect. Now, for the third one, what we're considering doing is that we would like to substitute the value of v we got here in equation 1 right into this equation 2. So let's do that. So now since v is equal to u plus at, or a plus at plus u, whatever, then putting it in equation 2, we have distance s to be equals to u plus, so I'm substituting u plus at, that's in the bracket, u plus at, then divided by 2 entirely, multiply by t. Perfect. So we can get rid of this one. We'll just note it down somewhere. Alright. So now we have, let me write it here without getting rid of it because we're using the reference. The first one we said v is equal to u plus at. The second one we said s is equal to u plus v over 2 multiplied by t. Alright. Now we are on to the third one. So simplifying forward, we have s equals u plus at divided by 2 multiplied by t. Alright, so I've used this addition to expand this entire bracket. Okay, Perfect. Then we have s equals u plus u is 2u plus at divided by 2 multiplied by t. Perfect. So let me distribute this 2. I can split it. I want to split the fraction, then I will distribute the denominator. So therefore this implies that s equals 2u over 2 plus at over 2 multiplied by t. Now this cancels. We have s equals u plus at over 2 times t. Now if we distribute the t, this times or displacement equals ut plus half a t squared. T times t gives us t squared. So that's the third formula, guys. This is the third formula for a linear acceleration formulas. So let's write it down. So therefore, the third one is given as the distance or displacement to be equals to ut plus half a t squared. Now for the last one, which is simply the fourth one, what we're considering doing is that let's consider squaring this equation. What would happen if we squared it? Now if we squared v equals u plus at all squared, then that will give us we can give this the square and give this one the square as well. Then we have v squared equals u plus at all squared. This still makes sense, alright? According to our energy algebra. So now we have v squared equals, now let's expand this one, u plus at multiplied by u plus at. Okay, we have v squared equals, so now u times u is u squared, then u times at is u at plus u at again plus u at, and finally plus a squared t squared. Perfect. So simplifying forward, we have v squared equals u squared plus, these are addable, that's 2u at plus a squared t squared. Okay. Now let's factor out 2a from here. Okay. Then we have v squared equals u squared plus, if you factor out 2a, then for this one we'll be left over with ut, okay, plus, now 2 is not here before, and we factor it out, so to make it balance, we now have half to be attached with it. 1a has left over is another a, then t squared. Perfect. By the time we multiply this thing back now, we got this back. Perfect. Now as you can clearly see, what we are having within this parenthesis correspond to this third formula we have for the distance of displacement. Eventually, upon substitution, we have v squared equals u squared plus 2a. So instead of this, let's replace it with s entirely. So we have 2as. And this is the fourth formula for the equation of linear acceleration. So therefore, we have v squared equals u squared plus 2ax. So these are the four formulas that help us to deal with problems involving linear accelerations. And now you know how they have been formed. So the next thing is to know when to use which. Alright. Now for you to know which of them to use to solve a certain problem, this is what I will suggest. First, write out the quantities given to you. All of them. Now, having done that, figure out what you are required to find. And the last step, decide by yourself, out of these four formulas, which of them can provide what you want to find. This is the answer you want to provide by yourself. Write out everything given to you, figure out what you have to find, and decide, out of these four, which of them can definitely work for me best. Now, it is important for you to know that sometimes two can work. The goal is for you to select your choice and the one that will be fast and the best for you. So, to put into account and practice, let's go over some examples. Example number 1. A bus traveling at 60 km per hour accelerates uniformly at 5 meters per second squared. Calculate its velocity after 2 minutes. Now, as you can clearly see, the 60 km per hour corresponds to the initial velocity, because that is the traveling speed or velocity of the bus. Now the acceleration is in meter per second, so it is important for us to convert this velocity into meter per second. Now the time is also in minutes. It is expected for us to convert it to seconds. So please make sure before you begin the solving or the solution, those quantities are in the appropriate units. Thank you. Now we are giving U to be 60 km per HR. Now A is given to be 5 meter per second square. And finally, T is 2 minutes. Now, what exactly are we required to find? Calculate the velocity after 2 seconds. The final velocity, the velocity is using currently, okay, after the 2 seconds. So we need the final velocity V equals question mark. Now we have written out everything we are doing. Also, we now know what we are required to find. The next thing is to decide which of this formula will work best for us. But before we do that, let's convert all these steps into the appropriate units. 60 km per hour to seconds, km to m, you multiply by 1000, so that's 60 times 1000. Now this is per, you divide. Okay, now the numerator has become m. Now hour to seconds, you multiply by 3600. Minute to seconds, you multiply by 60. Now if you want to do this again, from hours to minutes, you multiply by 60 again. Minute to second, so that's 60 times 60. And 60 times 60 gives us 3600. So you divide by 3600. Okay, now these two zeros reduces. So now 60 times 10 gives us 600 divided by 36. Now when I type that into my calculator, 600 divided by 36, I got 16.66, which is the same thing as 16.67. Alright, because the 6 were repeating. Now let's convert it. Okay, 5 meter per second is proper. The next thing is just the 2 minutes. Now minute to second, we said we multiply by 60. This is just 2 times 60, which is 120 seconds. Now the next thing is just to go back to our decision. So which of them out of the 4 will work best for us? Now notice that the first one, which says that V is equal to U plus 80, will definitely be the best one in this case. As U is given, A is given, and T is given. And this can help us to find V in no time. So that's how to make your decision. Alright. If you say you want to use V squared equals U squared plus 2AS, where is the distance? The distance is not given. So you need to find the distance given. And finding the distance, you need to use S equals UT plus RAT squared. You can see this will be a wastage of time. But at the end of the day, you still get the same results. Well, since we can have it using this one straightforward, what are we still waiting for? So let's move on. So therefore, according to the first law, V equals U plus 80, then the final velocity of the bus will become 16.67 plus the acceleration is 5 times the time is 120. Now, when I find the product of 5 and 120, that gives us 600. Then we have the velocity become 16.67 plus 600. And hereafter, now this 616.67, okay, meter per second. And that will be the velocity of the bus after 2 seconds. On to example number 2. When brakes are applied to a moving car traveling at 60 km per hour, it decelerates at a uniform rate of 5 meter per second square. Calculate the time taken to reach a velocity of 36 km per hour. So just like before, let's write out what we know or what is given. Now let's say the brakes are applied to a moving car traveling. So that's what is using the traveling currently. You understand? So the u, or the value of u, which is the initial velocity, is 60 km per hour. Now, when the brake is applied to it, at the end of the day, the velocity decreases to 36 km per hour. You understand? That is, the goal is just to find the time taken for this decrease in velocity. So the final velocity v is now 36 km per hour. Now we are given the rate of the deceleration. That's 5 meters per second squared. So a is equal to 5 meters per second squared. Now, it is important for you to know the difference between acceleration and deceleration. When both accelerate, it moves more faster. But when it decelerates, it decreases speed. And since acceleration is a vector, when a body decelerates, you have expected it has a magnitude of negative values. So therefore, for this problem, instead of 5 meters per second squared, it will be negative 5 meters per second squared to show that it is decreasing in velocity. Are we together? Perfect. Now the goal is to find t, the time taken for this change. And it has to be in seconds because acceleration is in meters per second. So these two velocities that are in kilometer per hour, we are expected to convert it to what? To meter per second. So just like before, 60 kilometer is the same thing as 60 times 1000 divided by 3600. And when we typed into calculator earlier, if I remember vividly, we got 16.67 meter per second. Now let's do 436. That's 6 times 100 or 1000 to say, divided by 3600. Now these two zeros we use this, 36 cancels out. And left over is 10 meter per second. Now we have all the quantities in the appropriate units. What formula will help us to find t? What do you think? Well, just like before, v equals u plus at is the best one to use in this case as well. So why? Because u is given, v is given, a is given, but t is what we have to find. However, this formula has all of them. So we are good to go. Before we begin substitution, let's try to isolate t. So now let u come to the side back. We have at equals v minus u, and eventually t equals v minus u over a. That makes sense. Perfect. So therefore, plugging in those values, we have time t equals final velocity is 10. So I've got it that way. I can remember minus 60. That's 16.67. Then divided by the acceleration. That's 5. Negative 5. Let it be negative 5. You understand? Because it's deceleration. So t equals 10 minus 16.67 gives us 6.67 divided by negative 5. This will be negative as well because this is higher than this one. Okay, perfect. Now the negative cancels out. Then we have 6.67 divided by 5. So the time is within 1.334 seconds. So as you can clearly see, this absolutely makes sense. As time is a scalar quantity, so time cannot be negative. It has to be positive values because it's just magnitude, direction is irrelevant. Are we together? So that's the solution to example number 2. By now you should have been getting used to the tactics and the logic of solving problems involving linear acceleration, or sometimes they call it equation of motion, problems on equation of motion. Regardless, the goal is just to understand the concept behind it. On to example number 3. A car accelerates uniformly at a rate of 10 meters per second squared from an initial velocity of 36 km per hour for 30 seconds. Find the distance covered during this period. So, let's begin. By the way, feel free to pause the video and figure this out yourself if you know what to do already. And after that, you can pause it and check if you got it right. So, we are given that it accelerates uniformly at 10 meters per second squared. So, A is 10 meters per second squared. So, since this acceleration, addition is expected to be attached to the magnitude, so we are good to go. Okay, now we are given the initial velocity because that acceleration is within, or it started from the velocity that is 36 already. It's not that it's starting from rest. And also, as you can clearly see, it is identified that the initial velocity is 36 because sometimes students used to find it difficult to identify the initial and the final. When that object starts from rest, the initial will be 0 and the final will be radian. Are we together? But when the object is coming to rest, the initial will be reading, final will be 8 into 0. By the time it stops, what's it called? Final will be 0. Are we together? Final will be 0. And when you are given that an object is moving already with a certain velocity and then a speed up to a particular velocity, so that former velocity is the initial, the one that is moving with currently is the final. So it's very straightforward and easy to identify. But I think the way I just explained recently will help. So hopefully it helps. So now we have the final velocity u to be 36 km per hour. Alright, then we have the time t to be 30 seconds. The goal is to find s, the distance covered during this change in velocity. Now, since you have to find s, you already know that maybe second or third will be the one to use. Well, let's see. Now, let's make some conversion. This is in kilometer per hour. Let's turn it to meter per second. But 36, we used 36 earlier, so we got 10 meter per second. Perfect. Now I can clearly see the best one to use in this case will be the third one. S equals ut plus half at squared. Time is given, initial is given, acceleration is given. So we're good to go. The reason why we will use s equals u plus v over 2 times t is because we don't have v. However, if you like work, you can find v using v equals u plus at. So after that, you can now go ahead and find your s. So it depends on your choice. So therefore, according to or upon substitution, s becomes the speed, then times the time, 30 plus r times the acceleration, 10 times the square of the time, 30. So 10 times 30, s equals 300 plus r, which is 10 to 5 plus 5 times 30 squared. So we have 30 squared, that gives us 900. So therefore we have s equals 300 plus 5 times 900 will be 4,500. When we have that, we have s equals 4,800 meter. Now you can have it in kilometer since it's very high, divided by 1,000. 4,800 divided by 1,000 will gives us 4.8 kilometers. So distance or displacement is 4.8 kilometer or 4,800 meter. So that's the answer to question number 3. And that's how to find the distance covered during the period. Example number 4. Now I want you to use this example number 4 as an exercise. Feel free to share your solution with me via the comment section below. Alright? I changed my mind. It was actually an example before, but I want to give an exercise. So use that as an exercise and feel free to share your solution. So let's just move straight away to example number 5. The distance traveled by a particle starting from rest is plotted against the square of the time elapsed from the commencement of the motion. The resulting graph is linear. The speed of the graph is a measure of what? Pause the video and read this question again and adjust it. What if you understand? What do they mean by the speed of the graph is a measure of that? So now, let's begin. Let's say the distance is plotted against the square of the time. So that's a distance time graph. Okay, let me draw the graph. Since y is plotted against x, so therefore the distance is what is at the vertical axis or the ordinate axis, while the square of the time is at the abscissa axis. Now, when this is plotted against themselves, the resulting graph tends to be linear. That is, probably in this form. Now, what they now say makes sense is that the speed of the graph is a measure of what? First, let's consider distance that is plotted against time. What will be the speed of the graph if the graph is found to be linear? From our knowledge in coordinate geometry, for those that take pre-calculus, we know that the equation of a straight line graph is y equals mx plus c, where y is the quantity at the coordinate axis, which is in this case distance, and x is the quantity at the at the abscissal or the horizontal axis, which is time in this case. Now t is a point of intersection. Now if the object starts from rest, just like the way they said the object starts from rest in this problem, then c will be 0. So therefore y will be equals to mx alone, because c will be 0. This is not plus c. So if y is distance, we have s to be equals to, and x is time t, then we have mt. Now dividing through by t, we have m to be equals to s over t. Tell me, what quantity is equal to the rate of change of distance? Well, since this is absolutely the speed, then we can say that m is the speed of the particle. So it means for a graph that is such that the distance is plotted against the time t, then the slope of that graph would be the speed of the graph. Now, this question is such that speed is plotted against time t squared. What would be the measure of the speed? That's what we want to figure out. Please, I hope you are following the logic. So we'll be using the idea we use now. Now, since they said it gives us a straight line graph, it means the equation will still be y. Let me use different color so you don't mix it up. It will still be y equals mx plus c. Now, they also say that this question starts from rest. This means c is 0. So y will be equals to mx because the intercept is 0. Now, they said the quantity at the coordinate axis or at the y-axis is x, and the quantity at the abscissal axis is t squared. Dividing 2 by t squared, m will simply be equals to s divided by t squared. What quantity gives us s over t squared? What do you see? Before we make any final answer or final statement, let's try to go back to the third equation we formed earlier from the equation of motion or from the equation of linear acceleration. Most especially the s equals ut plus half at squared. Now, for this equation, if the initial velocity is 0 for an object that starts from rest, because this thing starts from rest, then ut will be 0. Therefore, s will be equals to half at squared. Now, what if we divide both sides by t squared? You can clearly see that half a will be equal to s over t squared. But m is also s over t squared here. Can we say that m is equal to half a, that is the half of the acceleration? And now make a justification or make a clarification or a final statement that half a corresponds to the measure of the speed of the graph. Does this make sense? Yes, it makes an absolutely sense. We can't say it is the acceleration because acceleration will be v over t, not s over t squared. Though it gives us the same unit but different quantities. For acceleration, it will be v over t, not s over t squared. Well, from this justification, we can clearly see that half of the acceleration gives us s over t squared, the distance by the square of the time. So if the distance is plotted against the square of the time, the speed of the graph will be a measure of half of the acceleration. I hope this is helpful and understandable. I hope you find it straightforward. Thanks for watching. Feel free to share a solution to question number 4 with me via the comment section below. I'm going to respond to it as soon as possible. Thank you. See you in the next video. Bye for now.